All right, thank you for having me. So anyone? Oh, all right, got that fixed. Anyone use gRPC in production right now? Awesome. Love to hear your thoughts on it. So thanks for having me. My name is Bojan Jurkovic, and I'm from Fredericton, New Brunswick. I work as a lead software engineer at Cvent. Cvent is a company that makes software solutions for planning and managing conferences, conventions, and events similar to this one. But we're not involved with this event, so I'm here just kind of on my own. We're headquartered in Washington, D.C. We're probably one of the bigger companies you've never heard of. We have 3,500 employees, offices throughout the world, and 2 offices in Canada, 1 in Vancouver and 1 in Fredericton. And I should mention we are hiring, and the cost of living in Fredericton is more favorable than it is here in Toronto. Currently, most of my work at Cvent involves Java and Kafka, but on the side, I like to explore different technologies and learn new things and do some open source. So most of the efforts on that side for the past couple of years have been focused on gRPC, which is what we're going to be talking about today. I really commend all the speakers for doing live demos at this conference. I'm not that brave, so all the content will be available on my GitHub soon. But let's go back in time. Years ago, our applications were pretty simple. Usually we had a single server that served some kind of static content or HTML, and the browsers consumed it. Eventually, our applications and our servers got more complex and more dynamic. How we worked with data changed and evolved, and how we consumed it also changed. Today, browsers are not the only clients we have to deal with, and indeed we have different mobile devices and embedded devices and different platforms using our services. As our systems evolved to overcome the challenges of scale, both technically and organizationally, we started breaking up the monolith into microservices. A single PHP application became a number of different services written in different programming languages like Python, Java, Node.js, Go, and others. Our systems architectures has drastically changed over the past decade or so. Today, we are living in a complex, polyglot, distributed computing landscape where numerous services and applications need to interact with each other. So how do all these different components talk to each other in this new API-first reality? That answer, of course, is REST, or JSON over HTTP technically, and that's the de facto standard for REST communication today. We're all familiar with curl. Here we have an example of us creating a chart with the Stripe API. In a lot of ways, REST is pretty great. We're familiar with it. It's a text-based protocol that's relatively easy to debug. There's tooling for testing and inspection. It's well supported in most languages. Pretty much every programming language has a pretty complete and featureful HTTP client. So if we are building a REST API, what are all the things we need to take into account and consider? We have to define our types and our schema for our API. We have to deal with authentication. We have to document the API for our users, deal with versioning, status codes, and error types, how we handle redirects, how we handle e-tags and conditional requests, and a whole bunch of other things. I'm sure this is not even an exhaustive list. And even if we take the time to think through all of this and try to get it right, we still get users asking for a custom client library to interact with our API, even though we all know how to use HTTP. So REST API is not without its deficiencies as it is in the current form. HTTP 1 is not very performant. It's a text-based protocol that's developer-friendly but inefficient over the wire. Streaming is difficult, and bidirectional streaming is impossible. Also, not all operations are really resource-based. For example, if we want to ask a server to encrypt some text, we really maybe do not want our plain text to be saved on that server. Similarly, restarting some application or a host, an API to do that, does not really make sense. Is it a post? Is it a delete? I don't know. Or describing an image using machine learning or classifying a sentence or phrase for sentiment analysis. Those don't really align very well to resource-based APIs. Finally, there's always arguments and opinions on what method to use for APIs, single versus plural resource names, whether the ID should go in a path perimeter or in the body. I'm not picking on any companies here. These are very well established and popular API products. And Twilio, for example, uses 200 OK for GET, 201 for post and put requests, and 204 for delete, where Stripe uses 200 OK for all successful requests. So this is just the happy path. And even here, we see a difference in opinion on the very basic and fundamental factors of how REST APIs should be designed and structured. What we really want is the convenience of a local function call, but that's executed in a distributed manner. So that's a remote procedure call. Specifically, gRPC is a high-performance open-source universal RPC framework. It was originally a project at Google that eventually got open source, and now it's mainly developed by Google employees still, but in the open, it's open spec. There's an open request for proposals and request for comments for changes to the framework and to the APIs. The G in gRPC does not stand for Google, though. It stands for a different G word in every release of the framework. So we start with a protocol buffer definition file. A proto file is used to define our services. So it's an interface description language where we define our API and all our types. It's also an efficient binary serialization format. So here we're defining a greeter service, and that has one RPC method called sayHello. It takes a hello request as an argument and returns a hello reply as output. The hello request message has a string property name, and that has a field ID of 1, and hello reply also has a string property message, and that has a field ID of 1 as well. So just looking at this, it's clear and concise. We know what this service is all about, what this API is all about, the general idea, and how to use and interact with it. From here, we use a protocol buffer compiler to generate code for a specific programming language. So we could generate an actual working client implementation to interact with this service, as well as a server stub or a server interface that then we use to implement our logic and our API. So Proto-C compiler compiles these proto files, and that's all done via plugins. So it's very extensible, and you can write additional plugins to add support to other programming languages or extend gRPC functionality and the syntax and the grammar that you can use within these proto files. And this is what that code generation looks like. The first example here is we're taking our hello world.proto file and we are compiling it to Go code. So Go programming language code, and basically we would get all the types and the client library and the server stuff that we have to implement. The second example is the same idea, the same thing for Node.js. So it would generate JavaScript code to use on the Node.js platform specifically. Slightly different arguments, but the same concept. As you can imagine, the generated code is not to be edited, and it's not necessarily idiomatic for the programming language. So oftentimes it's optimized for performance and efficiency. And this is what the big picture looks like. So we take the client libraries that we get from generated code, and we use them in client services to call other services and the methods that they expose. On the server side, we take the server stub and we implement our API there. So gRPC provides 4 RPC mechanisms. One is a unary, so simple kind of single request, single response. There's also streaming, so client-side streaming and server-side streaming. So basically in server-side streaming, a client would make a call to the server, and it would be just a single message, and then the server would send a series of responses back. And finally, there's duplex or bidirectional streaming, and that's essentially a chat where the two parties are talking to each other. So I hope you can see how streaming can allow for like easier pagination mechanism where you don't need a cursor or you don't need a page number. A client can just say, hey, give me more data, and the server will send it. So underneath, this is all implemented using HTTP2. We heard yesterday that that's much faster, much more performant protocol. It's a binary protocol that's fully multiplexed, so multiple requests can happen at the same time on the same long-lived connection. The RPC is done using a binary version of the protocol buffers that we saw, but that's actually pluggable within gRPC. You can also use JSON if you want to. It's forwards and backwards compatible over the wire, and it's implemented in a whole bunch of programming languages. I'm not sure if this is even a complete list. Some of the programming languages, the implementation is actually done via native bindings to the C++ library. And you can also use it on Android and Objective-C to target mobile devices. And there is an experimental Swift support as well. All right, so some code. So this is what the server side would look like in Go. So in case you're not familiar with Go, for example, our generated code here that's result of the Proto-C compilation would result in an interface that we have to implement. To implement an interface with Go, you basically just have to implement the functions defined in that interface, and the compiler automatically knows you're satisfying that interface. So essentially, then we just need to implement our say hello function here, and the types hello request and the hello reply come from the package that's generated already for us, and we return a message back. The main function here is just a whole lot of boilerplate to set up everything. We create a server, we register our service, and we listen on a TCP port. One thing to point out here is that reflection to our register line. So that's basically a feature that exposes our service on this host for introspection by clients. So a client who doesn't even know about our greeter service, for example, can ask this server, hey, what gRPC services are you exposing, and how can I use them, and what methods can I call? On the client side, really quick, here we create an instance of a client that we already have, and we call a method to our server with a message. One thing to note is that timeouts are supported out of the box by the library itself, so we don't have to code any kind of specific logic. We just add it as another option to our call. An example here in Java, script for Node.js is something that maybe more of us are familiar with here. With Node.js, we have an option of actually dynamically loading those proto files, so we don't have to necessarily compile and use the compiled JavaScript code. So here we're just loading the proto file, and then we implement our server. The say hello function is our actual handler, and we return via callback, as is the standard in Node.js already. So we just use a callback to return a message, and that goes to the server. The main function is essentially the same concept as we saw with Go. We create a server instance, we add the service, and we listen on the port. And really quickly on the client side, we create an instance of a client, and we call a method with the arguments. One thing that's different here is Node.js uses a deadline to set a timeout. So deadline would be a future point in time when the request should expire rather than a scalar timeout value like we used in Go. But very, very similar concept. And a bit more complex example of a service that we may create. So this is to demonstrate how to create all the streaming calls. All we do is basically use the stream keyword, and we add it to our inputs or the outputs or both to dictate that those are streaming requests. So for example, here, say hellos would be a server streaming call. So a client would send a single hello request message, and then a server would send a bunch of hello responses back. And greet chat is a bidirectional one, and we can see how to implement that. So, code is not necessarily important here. Every programming language has its own patterns, has its own API and style to implement these semantics. But here is a Go code for our greet chat function. So the stream type here comes from our generated code. And we basically just read the types in from, or read the messages in from our stream using stream.receive, and we send them to the client side using stream.send. We know that the stream is, the request from the client side is done. That means the stream is done using the end of file flag here. And then on the other side, this is Node.js using the client to interact with this server. So the client, we just call our greet chat function that returns immediately a regular duplex Node.js stream that maybe some of you are familiar with. So we just use that stream to write messages to it, and that would essentially send those messages to the server, and then we use the regular data event emitted by the stream to get the messages from the server. So gRPC has a concept of metadata. This is similar to headers that we are familiar with in REST API architectures, and indeed it's actually implemented using HTTP2 headers underneath. So metadata is used to add additional contextual information to our calls, so things like authentication, request IDs, or tracing. And this is just a Go client example. There's a utility function to add key value pairs to our call, and we add a token and request ID and then send the request along to the server. And on the other side, for example, in our Node.js server, in our say hello handler, we can use the call arguments metadata property to get the metadata, and then we can get a JavaScript object out of it and just print it out, and we see our token and we see our request ID. As well, gRPC itself adds a user agent metadata field. So we have here, we can see that gRPC Go was our client using version 1.16. And there is a command line interface, official command line interface to use with gRPC, and very quick walkthrough of how that would look like. So we can use the command line to basically list all the gRPC services on a specific host and port. So here we see that we have hello world greeter service. So this is using that reflection mechanism that we saw earlier. And then we can ask a specific service to kind of list its own definition and list what methods we can call. And then finally, we use the call command to actually execute a call against that server with the arguments, and we get a response back, hello John here in this case. There are other third parties or open source command line utilities for working with gRPC that in some ways might be a little bit better than the official client. A good alternative is gRP curl, so basically gRPC version of the popular curl command. So you're probably wondering if we can use this in the browser, and the short answer is kind of. The long answer is there is an official gRPC web project, and it became generally available at the end of October, so just basically a month ago. As you can guess, it's also a product compiler plugin, and we basically use that to generate JavaScript code to use within our Vue, React, and Angular applications to call our gRPC backends. To enable the browser support, they did have to change the protocol slightly of how that works. So you can still use protocol buffers. You can actually use a gRPC text format as well, or JSON to call the API. But because the protocol is slightly different, there is a middle proxy that we require to do the translation between the browser requests, and then it would then translate those requests to call our gRPC services in the backend to fulfill that request. So the gRPC project, by default, they recommend an Envoy proxy. If you're not familiar with, that's an open source proxy server done by Lyft. And if you've been following reInvent this week, basically AWS announced that they have a new service mesh product, and that's actually using Envoy, so it's a pretty popular proxy server. And gRPC does provide an example configuration files that you can use to set this all up. Nginx can also work, but the official recommendation is to use the Envoy proxy here. And We might want to actually provide a REST API alongside with our gRPC services as well. So we have a couple of options to accomplish that. One is to use a gRPC Gateway project, which is also a plugin to the compiler, and that basically lets us define what the REST API will look like within the proto file definitions. So here we're saying our say hello method will be exposed as an HTTP endpoint at the path/say using the method get. And then the end result of that compilation would be a fully functioning server proxy implemented in Go that basically exposes this REST API, and REST API clients can talk to it, and then it translates those requests to gRPC to call our actual gRPC service. An alternative is to use Envoy. Again, it has a kind of a transcoder filter that you can implement and add, and then configure the REST API itself, and then it can handle the traffic. Both of these solutions have intricacies with how they handle streaming requests, and neither solution supports bidirectional streaming, so it's important to keep that in mind. So if we build our service, it'd be nice if it never changed, but that's never the case in the real world. So there's a few things to keep in mind as our services and APIs evolve. The name of the fields in those messages are less important than the field numbers, the field IDs that we saw. So we can change the name and everything will actually work technically. Obviously, logically, that change might mean something, so we may have to change what our API does. Like if we change a name to a user, that may not be the same concept anymore. So we do not want to change the type or the number or the ID of a field. Adding fields is safe. When we want to remove a field, we need to deprecate it first, and there is a mechanism for doing that. And when gRPC servers deserialize those payloads, those protocol buffer messages into actual types within our programming language, if there's a field defined in a message that's not present in the payload, it's always defaulted to some value. So for example, a string will always default to an empty string, a boolean will always default to false, an integer will always get defaulted to 0. So it's important to know that side effect and kind of account for it in our implementations. Finally, if we need to specify a version within our API, usually a good practice is to do it within the package. So those protofiles, you can actually specify package name, and then when that gets compiled to code, it will have a meaningful result. So for example, in Java, that would be also the package name. In Go, that would be the import path. And that way, when we update the version, for example, it will be an explicit update. The clients will have to explicitly update that dependency to use our new types and our new API. So let's quickly walk through this process of adding a property to our hello request. We can add a Boolean capitalized flag here, and then release it as version 2 of our API. And generally, servers would be released before clients. So if we have a client that's version 1 talking to our server, the client does not know about this capitalized flag at all. Remember, it's using our old message format. It will send it along. On the server side, it will get deserialized. The capitalized flag will not be present in the message, but gRPC defaults it to false. We handle it, and then we reply to the client. Everything works out. And then, in the next step, we want to remove name and replace it with first name and last name. So in version 3, we're going to deprecate name and release that new protocol buffer definition and new clients, and give our users the time to change their code to remove using name and start using first name and last name. Once all of those changes have been done, we can actually then take a further step to reserve that field number and the field name, and that all that does is provide a guarantee and prohibits developers from accidentally reusing those field numbers and field names in the future changes to our messages. So for example, if a developer a month from now added a string middle name and assigned it a field ID of 1, the Proto-C compiler would actually fail to compile that. So we want to keep all of our protocol buffer definitions in a single mono repository. Here's an example of all the Google cloud services APIs, they are all actually defined in protocol buffer definitions in a single GitHub repository. So that way it lets us, its centralized place lets us have a common place where we can do the normal pull request code review process on any type changes, API changes in our definitions. We can also have tooling, automated tooling to test compilation for any programming languages we care about, to do linting and other things. So, and then services will take those protocol buffer definitions that actually generate code themselves and version control that code and that dependency themselves. And gRPC is a pretty good tool, but it's not a silver bullet. You still have to think about proper architecting and designing our APIs. Services should be small and concise with a small surface, kind of do one thing well. It's important to have an API style guide where we have an agreement of what like our functions will look like, what the naming of messages is. So things like, do we use update versus save, or new versus create, and things like that. A really good starting point is actually to reference the Google Cloud API Design Style Guide. That's a great resource, and it actually goes over there, designs for both REST APIs and gRPC APIs. So I'm sure it's useful for a lot of you here. And gRPC is now without its set of challenges and problems. Load balancing has been an issue forever. That's finally a much improved story this year. So basically Envoy, the proxy that I mentioned earlier, supports gRPC load balancing. Linkerd, which is another kind of service mesh product and project, supports it now as well. And Nginx recently added support for gRPC. And this is all at the layer 7, if you're familiar with the networking stack. So it's at the application, the top layer supported. The browser support became generally available a month ago using gRPC Web, but it's still a bit cumbersome. It only supports like server-side streaming and unary requests, and we still need that intermediary proxy, which adds additional operational overhead. The fact that we're dealing with binary data now makes debuggability and inspection of requests especially challenging. We can't just hook up Wireshark and see what's going on over the wire or log things. So there's quite a bit of work going on in the project right now to add features and improve this capability. And gRPC on the official website has a lot of documentation and reference, but most of it is like basic tutorials on how to get started. So any more advanced topics on implementation details, or for example, if you care about what the threading implications are on how requests are handled in your Java server, for example, you sometimes have to go through markdown files in GitHub repositories or different mailing list posts, or actually go in the source code and figure it out yourself. So it's lacking in more advanced documentation. There's also poor feature parity between languages. So gRPC has a concept of middleware or interceptors, so both on client side and the server side. So for example, on client, we can say we want this function executed before any outgoing request, or on the server, we want to like have another function that just logs the request before we handle a call. So Java and Go, for example, both support server-side and client-side middleware, but Node.js only has client-side middleware, and there is no server-side middleware at all in the gRPC Node library. There's also an inconsistency between semantics and API in the languages, and we saw an example of that with like timeout in Go and deadline in Node.js, for example. This is just me taking a screenshot of all the GitHub issues of people asking for server-side middleware for Node.js. There are other open source libraries and frameworks that implement this functionality on top of the core library, but it's not present in the official module. And we've all kind of seen this concept before. 10 years ago, we had SOAP XML, and maybe some of you are familiar with that. And it was tied to XML. Protobufs are actually pluggable in gRPC, so we can use JSON. Maybe in the future we'll use something different. as actual payload and RPC mechanism, but we still have the general concept the same. SOAP XML was tied to XML. It was unnecessarily complex and inflexible with regards to compatibility, and it did not have streaming support. There's Swagger, or OpenAPI, I think is what they call it now, and that is a good tool. It's machine readable. There's a lot of tooling for client generation, documentation, for many programming languages, but it's still very much tied to current HTTP REST API architecture. Performance is still an issue. There's no streaming. And it's also, in my opinion, very verbose and cumbersome to work with. Like a single post endpoint API takes lines and lines of JSON to describe, whereas a single RPC method is literally just one line of code in gRPC. Thrift was a project that came out of Facebook a few years ago, and that was a kind of a promising serialization format, very similar to protocol buffers that we saw. And they tried to build an RPC mechanism on top of it, but it never really got to the success that gRPC seems to be having. And I think that just in part, at least, due to the sheer level of effort required to implement all of this and implement support for so many programming languages. MessagePack is similarly very, very flexible and well-supported serialization format. It does not require a schema, so it's basically binary JSON. So you can, if you need the flexibility of unstructured data or schemaless data where you don't know what the picture will look like, what the shape of that data will look like, it's a good option, but then you'll lose all the definition of your API and coherent picture and maintainability of having it well defined. I did want to call out Twerp here. So that's also an open source project from Twitch that got released a couple of months ago. And they basically looked at gRPC and they're like, yeah, we really like this, but we're not comfortable with the hard HTTP2 requirement. So they just simplified it, took some features out, made it easier to work with HTTP1, made it easier to work with JSON alongside with protocol buffers. So it is actually a really great alternative if you find yourself in that kind of scenario where you need something, you like the idea of gRPC, but you want it to be a little bit closer to REST and work alongside REST APIs a bit nicer. And finally, there's GraphQL, where I think most of us are familiar with that. A really great option for our front ends to selectively query our API and get the data that they need. It's human readable, but it's also schema based. It's got types, but nevertheless, it still works on the current HTTP REST APIs. There's no streaming, and I'm not quite sure that it's ideal for like service-to-service communication as it is for like the browser talking to an API. But where we are talking about GraphQL, I do want to mention this project called Rejoiner. So that's a tool that basically lets you create a GraphQL API that will take GraphQL queries and translate them to all your gRPC services in the backend. And then it knows how to take those responses and stitch them up together to basically then return the result of the query to the browser. So very interesting tool there. And there are lots of users of gRPC who are using it in production already. Google obviously uses for a lot of internal products as well for Google Cloud Services. Pretty much most of Square's internal RPC is done using gRPC. Similarly for Lyft, I know Netflix uses a lot of Java gRPC and Node.js gRPC as well, and there's a bunch of others. So should you use it? And of course, the answer is it depends. Like everything technical, you really need to know your own needs and requirements, the context you're working with, and it's important to always do your own evaluation research and really understand what compromises you're willing to make or be okay with for what benefits when making any kind of decision on any kind of technical choice. So I do believe gRPC is a pretty good option for an RPC mechanism, at least for inter-service communication right now on the backends and potential in the future for browser side as well. So I encourage you to at least experiment with that, and you might learn something new and it may work for you. And I can take questions, I guess. Thank you.
Hi there. I just want to know, why don't you think GraphQL is good for server-to-server communication?
I just don't think it aligns very nicely to like RPC mechanism like this. I'm not a GraphQL expert. I don't know, like, really, personally, I just don't think, like, I'd rather just make a function call and it gets executed, and I'd rather have, like, generated classes for all the types I'm dealing with. So, yeah, I don't kind of want to be, like, making selective queries on what data I want from like a user API or an authentication API. But maybe it is, and maybe that will change in the picture, and maybe it's my own ignorance. I don't know, because I'm not a GraphQL expert, really. So good question. Maybe you know better, I don't know. Talk to me later. Yeah.
When did you decide to use gRPC?
So we are not using a Cvent, actually. Cvent is a company that's been around since 1999. We have basically hundreds of services right now. We do have established patterns, established frameworks, established client libraries already for pretty much everything we do. It's not like we just spin up new services and new projects and products every day. I do think as it's becoming more popular, it is definitely something that we might explore and look into for sure, for at least inter-service communication. We are in a big move to AWS right now, have been for the past year or so, and especially with the new service mesh that does product that does support gRPC, it's becoming a more of an attractive option, perhaps. Yeah, so we basically everything here, like I've been playing around with gRPC for the past couple of years and do some tooling and stuff on GitHub. So it's just based on my own personal experiences, I guess, not necessarily a production operational perspective. All right, thanks a lot. Oh, that's it.